One. Interchain Live is here with Ryan Munn. We are live. We have Sunil G. Singh here with us today with ServerCube.com. ServerCube is a very interesting device that is decentralizing deep AI processing, VR processing, and really helping us expand the reach of technology. Sunil, thanks for joining us today.
Hey, thanks so much for having me on. It's really a privilege. Thank you.
Awesome, awesome. Well, thank you for the work you're doing. Share with me a little bit, I guess, some background. What kind of brought you into this project with ServerCube?
Well, I've got a healthcare IT background for the last 21 years. I've run a small healthcare IT firm organically from the ground up, and it has, over a long period of time, it established itself with a lot of the major pharma, biotech, and healthcare providers and government agencies like the NIH and the NCI as well. And what's happened is I've tried to take some of that experience and understanding how global organizations deal with their infrastructure, deal with their computational processing needs, and look at different ways that that model can be inverted, it could be changed, and it could be made more efficient. It could be streamlined as well. So that's kind of the genesis of how I got here. Originally, the idea was to take old servers nobody wants and distribute them. That didn't turn out to be economically viable, but I'm still working on that. But we evolved then to say, okay, what is it that people really need? Or what could be profitable on a unit cost basis? And more importantly, how could you provide a benefit to whoever participates in building that infrastructure? For us, that was really key and important. Yeah.
Awesome, awesome. Well, it's a great mission you've got there. And, you know, so actually, I want to touch base on something there. You said about recycling old equipment. And I think that's the key, is figuring out the best and most efficient ways to recycle old equipment, because we make such fast leaps in technology that when something gets old, it really does get, you know, fairly useless. And there may be some things we could do with it, but it starts getting really hard to repurpose it in the demands of the current technology pace, not to mention efficiency, right? I mean, things are so inefficient when they're 18 months old or 24 months old, especially if they're 5 years old. So, so recycling, I think, is a big challenge in the tech industry, but it's also something that, you know, all these materials can be used again. We just have to get better and better at using them.
Yeah, at least with the model that we built for ServerCube, you know, we tried to keep this in mind from day one, because we're doing 3 kinds of distributed computational processing. One is blockchain as a service, and the other 2 you mentioned, which are deep learning AI and VR modeling as well. And all of these things require high GPU or high GPU and ARM combination processing, not so much CPU processing. And what we determined is, as you look at the kinds of applications these devices can run, there's a life of what they can do, you know, from an economic perspective. But in parallel, we're looking at how to distribute these devices when they reach our commercial end of life, also to nonprofit institutes as well, and primarily research institutes, universities, and things of that nature, where they could be useful in solving public domain problems. For example, one of the public domain problems that we strongly feel needs more computational power is a project that was introduced by Stanford. It's called Folding at Home, and it basically deals with protein modeling and how that affects certain types of tumor growths and other kinds of diseases. And I guess the point is that, you know, if they had, let's say, 10% of the processing power that was used for Bitcoin, you know, they would be able to make these huge gains and what they understand about this protein modeling. So we hope that after a year or 2, let's say 2 years of ServerCube having its devices and distributed, and when we take those old devices back, we're going to be able to also, you know, distribute it and provide it to these research institutes.
So have you actually done any research into folding coin or cure coin protocols and running those on your servers?
Yeah, we started to take a look at a lot of different protocols that could be run on the ServerCube network. You know, the idea is that we build these devices. We're trying to get the cost down as low as possible, but high GPU, high ARM devices, and we send them to, you know, libraries, churches, museums, schools, small offices, and in some cases residents. But we pick these places that could be really incentivized if we, let's say, paid part of their electric bill, or we provided Wi-Fi, or in the case of Turkey and India, and in the US, obviously the discussion I'm having with you is to amortize the cost of installation and provisioning solar power as well. And we think those models are all win-win models. We don't want to charge anybody for the use of our device. We want to give it to them for free and give them an incentive to use it. And in turn, that aggregation of computing power is what we then sell to our customers in the form of, per transaction charges of blockchain as a service, or providing virtual machines that can run AI processing and VR modeling, which commonly people would look at as gaming as well. And because the proximity is close to where people are actually using the applications or the systems, they get a speed benefit as well as cost benefit. So, this is the basics of the model. Our goal is to answer your question, to be agnostic in terms of the platform. So we've already looked at Golang, for example. We're looking at our chain right now. We've got a lot of work in trying to see how we can get our chain to run on our platform, as well as Ethereum-based protocols. But the goal is to be agnostic for whoever wants to come along and say, hey, we've got an application that needs high computational power, needs to be distributed. We're looking for advantages and time latency. We want to welcome everybody and say, hey, come on, we'll get it ported over there and let's do it. Same for the use cases also as well. It's the same kind of idea.
Awesome. And so how long has this project been going on? When did ServerCube get launched?
Well, in my head, it's been going on for a while. Maybe, I guess it's going to be August soon. And I was banging this around last summer. I was talking to my buddy in a swimming pool, and I told him the very old server idea. He said it was the dumbest idea he ever heard, but that was the start of it, basically. He's the CIO of another company, and he's one of our advisors also too. But basically, it started from there, and then we started really, I guess I finalized the concept probably in October, I would say, something like that. We did our first blockchain conference at Halloween and November 1st, the day before my birthday. That seemed to be a very significant time in my life. I don't know why, but then a lot of things happened. And then by December, we started looking at building the prototypes and so forth. And that's when I started my first fundraising events. By January is when we did the incorporation. And then, we tried to launch this ICO private sale around the March timeframe, something like that, to have that running in parallel. And our efforts right now are with private equity raises as well also.
Okay, yeah, it's very exciting. So how much have you raised initially?
So I've done, having run a business organically for 21 years, you learn a lot about debt financing. So really great at borrowing. I try to learn from my uncle Sam. So, he used the same methods to try to get things going. So what we did was we bootstrapped, I'm going to say somewhere around 350 to 400,000 in the basic prototypes, and to get 39 units built. That's what we call Generation 1. And those were expensive also to make, because not only were we learning about the build process and the software and getting a team together, but the cost of certain components was artificially high at that time. So it's a terrible time to build a supply chain. So we sunk a lot of costs in there about that amount. But the Generation 2 that we've developed is more efficient, and we've learned how to scale the supply chain once we can put large enough orders in. So that's going to drive our costs down. We also have some R&D initiatives that we're talking with what they call AIBs, add-in board manufacturers. They're interested in working with us if we can build the order chain to basically build new kinds of hardware that would be more efficient to run in these kinds of devices. We've got 200,000 in financing, which is asset financing. That's the value of the machines. I've gone to 3 banks and they've loaned against the value of those machines as well. So that's another 200,000 that we put in. And then we've got another 150,000 in pledges on the private sales side right now. I won't go out and collect that until it hits around 2.5 million, but that's basically how we've started that end of it right now. And we've got I don't know. I'd say we've got 2 semi-interested parties right now, and looking at that private equity, the seed piece of it also. Yeah.
Awesome. That's really exciting. It's really exciting. So, and has any of that been a token sale so far?
No, we haven't done anything in terms of either a formal pre-sale or a crowd sale yet. That's also another lesson that I had to learn, that it's not anything to do really with product development or anything like that. That's a lot to do with SEC laws and the market right now, and crypto being somewhat difficult, I think. So our intention is to do a launch probably, I would say, late 3Q or 4Q of this year. Once we get our seed in place, we'll be able to do that and execute that properly.
And what is the current monetization model? You have some revenue coming from these processing customers that are using your servers to run their algorithms?
Right. So right now, everything is in proof of concept and development stage. One thing that I learned is that if you want to have developers come into your platform, you really can't charge them for it to start off at this moment. But we have commitments from, for example, from one of our advisors is the CEO of a company called LiveGenic, and he's built a company that uses blockchain for insurance claims processing, and they've agreed to run on our platform also as well. So just trying. Oh, it looks like Steven's joined also.
Hey, Steven. Yeah, sorry to interrupt, but Steven, thanks for joining us.
Hey, no problem. I'm sorry I was late.
No worries, no worries. So Steven from Transcend Engineering up in Bethel, Vermont has joined us and is hoping to host one of your servers, Sunil. So actually, this kind of is a perfect segue. Walk us through what this actually would look like for somebody hosting a server.
Yeah, so if you were going to host a ServerCube device, there's a couple of models that we're using in the US. So one of them is to take a look at your electric bill, and then once we know what your electric cost is, we can pay a certain amount over that, and so we directly pay the electric bill. That's the model that we think is easy and easiest in the US. And in exchange for that, you basically get this device, you plug it into the wall, and you connect an Ethernet cable to it, and then you leave it alone. From that point, we're able to remotely check everything and handle it and so forth. So it's designed to be, as least intrusive as possible, not to bother people. If you're a tech guy and you want to look at it, that's a different story, but it's basically designed to be set up like if you put this in a library or church, you don't want to have anybody else having to really do any work with it or anything like this. It's a real plug and play kind of situation. And then as your electric becomes due, we make an account and then we pay that out directly. In India, we're doing this already with some test customers also as well. And so the model is like, you get a benefit out of it, but we don't want to create a tax burden for you either. If I paid you over a certain amount directly, then your uncle that I mentioned earlier, Uncle Sam, will come back to you at the end of the year and say, hey, where's my share? But in this way, you also get a benefit without having to worry about the tax liability too. So we like that model. In some cases where it's more rural, we have Wi-Fi hotspots in the device. And so there you would pay your own electric for it, but then you would get a free high-speed Wi-Fi also. So we're looking at this like in West Virginia and some parts of Texas also as well, because it's cheaper there.
So Steven, what about ServerCube? What kind of model or benefit would be interesting to you, or what else interests you about ServerCube?
Yeah, so what intrigued me when I first read the description of it on your website, when Ryan said he had met you, was the idea of the distributed cloud computing. Could you tell us a little bit more about whether that model is still alive, or if it's going to be exclusively a mining operation?
No, I need to be clear about this. We don't have an intention to do mining much at all. The reason that mining comes into the picture is when you're looking at ICOs and crowd sales. It's a model that people can understand. They get their head around it very easily. But what we really want to do is offer a private blockchain as a service, AI processing and VR modeling. And if you think about the situation a little differently, you look at Google, Microsoft, and Amazon. They have huge data center capacity that's available to them. None of them are commercially doing mining. Why is that? because they're able to figure out how to do other things that are much more profitable as well. And so that's definitely our model also. So if you look at how distributed computational networks work, and let's say if you take a project like Golem, for example, you're talking about somewhere around a 20% loss of computational efficiency because you have distribution of nodes. So if you agree that that's the case, what you have to do is you have to scale a lot of nodes so that they work together, right? And so that's exactly our model. That's what we're able to do. We've got some proof of concept models running right now. What I had explained earlier, so for blockchain as a service, we're looking at different blockchain protocols that we can run. We've got a proof of concept for insurance that I mentioned earlier. We're bringing one on for real estate. And we have another advisor who's coming on who's going to help us build one for gaming as well. So our only problem is, how to go out and sell that service once it's available, and to be able to hire our developers and engineers to be able to push those forward. So each one of those is about a 2-month runway to do each one of those POCs. So the more people that I can hire to throw at it, the more services ServerCube is going to be able to offer right off the bat. Yeah, that's the idea.
Awesome. What's ServerCube? What's the the operating system and underlying hardware based on?
Yeah, so that's a great question. So we have two versions. One's a Windows version for some kinds of applications, but most of them are Linux based. And for Linux, they would either be Ubuntu. At this point, probably in some cases, we would take Red Hat also as well. It really depends on those specific applications. But most of the things that we're distributing right now in all three of the applications, the BERT applications for blockchain as a service, deep learning AI, and VR modeling are all based on open source code. Yeah.
Awesome, awesome. And what's the hardware? Or you've got two models now, right? You've got the first series, like the Series 1 hardware,
generation,
and then generation 1.
Yeah, and the generation 2. We basically assemble the units mostly from well, the motherboards are really based on gaming hardware because those are the ones that can run the most computational power, and we carry AMD GPUs in the devices, and it's usually either 6 to 7 GPU cards that run, and each one of those is a dual core card that's plugged in with the PCI bus. So that's basically the main model. There's space in there for high-speed USB cabling that allows you to put multiple Wi-Fi hotspots in there. And what we're really trying to do is to see if we can get 5G termination points installed in the devices. I have a meeting next week with someone who knows something about how to reach the right people in the cellular carriers or the telcos to be able to do that. And we think that's going to be a huge innovation if we're able to get that built into the hardware as well. Yeah,
absolutely. And seed for future thought. I've been in conversation with a company that has some very significant wireless technology we could talk about.
Yes, right. I remember you mentioned this earlier, and I'm excited to talk to you guys about what's going on with solar, especially a place like Vermont, where we can see if that amortized model works here in the U.S. also too. Because
absolutely,
that might be it's really beneficial.
It's been good to see some of that collaboration between some of the rebates and incentives come out, but also some of the credit unions and banks that have worked with these programs to make them happen. So we'll make some of those connections and introductions, and I think it's a good combination here.
Yeah, I mean, the way we see it is, if you have financing companies able to amortize that cost of solar, or the solar distributors themselves, we can show, because at least we have models that work in India for this, we can show that amortized cost is much less than what you can gain in terms of revenue from the devices. Now our revenue models are based on a simple comparison. We take the equivalent computational power of these devices. We say, okay, it's equivalent to 2 of a certain kind of virtual machine that's available from AWS, and you can do the cost comparison there. And so once you understand that model, then you can understand why it's profitable and why it's scalable, and in this case, why it's beneficial to the user, the institute, or the people working to build the infrastructure as well.
So Sunil, I have a kind of multi-part question for you about that, and the idea of using renewables like solar.
Sure.
So in Vermont, we have a sort of a very forward-looking and generous legislative model that kind of forces utilities to do group net metering. And these can be distributed groups so that you can share, solar panel production at one location and be a member of a group where your residence or your business is remotely located from that. As long as you're served by the same utility, you get to pool all that together and get net metering against your bill from the PV generation. In fact, I know several people who have sort of excess credits that they don't use because their PV generation exceeds their demand. And I'm also wondering about small operators. Have you thought about the idea of, or would it not even work because the demand on your demand profile is different than their energy production profile? I was thinking about whether you have thought about activating the server cubes when excess production is available and deactivating them when it's not.
Yeah,
because of the load balancing problem on solar generation.
Yeah, so we've looked at this problem, and in fact, in Texas, there's a different problem, not necessarily related to solar, but it's a wind problem. And so what happens in Texas, you've got more or less free electricity at night from like 10 p.m. to 6 a.m. because the demand's low and they have a bunch of wind stuff out there. So that keeps blowing, right? And now they're throwing out this excess power, so they can't sell it for anything. And so it's a similar kind of situation here, is to be able to suck up that additional demand. I'll tell you, in a place like India, the way that the solar is set up, it's because the country didn't have a stable power infrastructure ever, right? In terms of the development of an electric infrastructure, people had to become very used to having blackouts and brownouts constantly all the time. And this still happens today in India. So when you install solar in a place like that, it comes with an inverter bank. This inverter bank is basically a battery set that's getting recharged at the time that there's available power, and then it flips over to use that battery set at the time when there isn't any external power. Because all houses are built that way and all businesses are built that way, they've got basically a battery capacity system built in that provides continuous power to vital devices that you would have in your household. If you had like a heart monitor or a refrigerator, whatever it is, that's how it works over there. So we think that this model could be very helpful also if we can amortize that along with the installation of the solar to have that kind of inverter backup. But that would provide more continuous power. But to answer your question, in places where there's excess capacity, so for example, in the state of California in 2017, there were 9 days out of the year where California actually had to pay Arizona and Nevada to take its excess power because it produced too much power. They had no place to put it on the grid, so they have to pay other states to take it from them, right? Well, if I was a California electric bill payer, I would be irate at that moment to find that out, that the state actually is throwing away electricity. So this problem of excess capacity, it's all over the place. And so to answer your question, yes, because we can remotely turn down the processing capacity of our devices, we could run them at extremely low power, or less than 100 watts, in some cases 75 watts the majority of time. And then when we could see, hey, there's additional power available, then we can turn that up and draw up to 1,000 watts at that point. And so in this way, we'd be able to suck down that excess capacity at any given time. And it's really just a question of automating those notifications and being able to pull that. We've got 4 machines dedicated to go to Peru. Getting things like computers in and out of Peru and in an elevated space is a different problem. That's a logistical problem. But once we get them up there, they're going next to a hydroelectric plant that is also throwing off excess power. And so they want us to see if our concept can work over there as well, where we have a small device, we can put it anywhere that they have space for it and start sucking up that additional power that otherwise goes to waste. So to answer your question, yes, definitely looked at this, and we think we've got more flexibility because we're not bringing a container, for example, like another company's doing. We're bringing a small enough unit that you could distribute and put wherever that excess capacity is going to be. And obviously, like you're talking in Vermont, where there's pooling, or maybe that's a great way to have that model work.
Yeah.
Great. Yeah, so I get excited about the idea that with AI applications, obviously, when they need to be on and serving their purpose, right? You can't choose when to consume their power, but you could potentially choose when to provide the additional training as they continue to learn, right? And kind of pool that up and
exactly
expend that when the power is available.
Exactly. Yes, because we can distribute parts of those learning data sets across multiple nodes. As you know already, this is how, for example, TensorWorks or Google TPU2 is basically the same kind of idea. The problem with their model, we think, is that in order to use it, you have to go into their data center, and that's located in Santa Clara, California. For example, for the fintech companies that we're talking to, there are two use cases that we have. One is for settlements using blockchain, how to drive that cost down, and then also how to get that processing in a way that those nodes can be controlled by whoever wants to do those settlements. But the interesting one is around AI also, where they want to do real-time trading and they want an AI machine to basically tell them what they should do at that moment in time. And so in order to be able to do that, it's exactly what you said. There's different times when you want to learn, when the market's closed. And then the other times when you want to trade, then you want that thing cranked up all the time, you know, to be able to say, okay, here I've made this suggestion based on my AI algorithm. So we think that's going to be a huge market. Yeah.
And can you tell us about, I mean, maybe getting a little too far into the technical weeds, but is there a sweet spot or a threshold below which your network bandwidth, just won't support what a ServerCube needs to do?
Yeah, we tried to set the minimum at 3 Mbps, which we think is very achievable, even with Wi-Fi hotspots. What we know is for certain kinds of applications, so when you're talking about blockchain as a service, and if you take the simplest algorithm, if you have a private blockchain that you need to replicate the nodes to, it's really, once they're synced initially, right? Once you pass that, then you're able to basically push those transactions out to each one of the nodes that's up and running at that point in time. And that turns out to be a very small amount of bandwidth that you're able to do that. Similarly, for the data sets, for the deep learning AI, again, it's a question of distributing them to the nodes that are going to do the learning on that subset of the data. But again, the same thing. You can push over a long period of time. After you're done with the push, then you're able to go ahead and get the processing done, which is really where you need to do the work over there. Because we've got additional storage both in SSD as well as in SATA drives, that gives us some flexibility there, as opposed to where people look at mining rigs, they're like 64 gigs of SSD. You can't do anything useful with that, and so we've got a couple of TB sitting in there locally that can be used basically for handling this kind of data set. So I guess the point I'm making is we can meter down most of because we're only working on these kinds of applications, we can meter down most of the network connectivity. When we get into gaming, that's a little bit of a different story, because the bandwidth usage has to be higher. But in that situation, what happens is we localize that processing within that group of nodes. And we do that for two reasons. One is so that the latency time is reduced from the machines talking to each other. And secondly, it turns out that for a lot of gaming applications, people want physical proximity to where they are anyway. And so in that situation, they're able to control the nodes that they can actually have some kind of knowledge about where it's running. That's an advantage in that community, in that application set. So it also extends for general VR modeling, where like in a country like Turkey, for example, it's going to be difficult for them in the next 20 years to build their own local supercomputer for various reasons, whatever it is. There's only 4 countries in the world that have large supercomputing computational machines that are the traditional large centralized supercomputers that you think of, right? And the top 3 are in China now, and then there's 3 after that are in the US, and then you've got Korea and Japan. So a place like Turkey could say, hey, I've got this computational power that's equivalent to a supercomputer, and it resides within my borders also as well. So that gives them an advantage if they want to use that for another purpose, a government purpose, or things of that nature too.
And can you tell us about how you address security concerns? So for instance, someone's doing AI work on ServerCube distributed cloud, and they've got data assets that are, in most cases, that's really their competitive advantage, right? Training sets and whatnot. And these are being distributed out to ServerCubes to train their AI and do that. How do you protect from individual ServerCube users who have malicious intent or nefarious intent?
It's a great question.
dealing, training, weights, and whatever.
Yeah, so all of that, first there's basic encryption that runs everywhere in the machine. But more importantly, if we had specific kinds of AI data sets that needed to be handled carefully, we've got provisionings where at the assembly site, we can also store encrypted keys. For example, if they wanted to attach encrypted USB keys, these are stored internally in the device. So the user can't externally access that. It's the same for the Wi-Fi also as well. We could provision that by installing it into the device, and the case is physically locked. And because of that, there's also a chassis intrusion switch as well. So that'll shut the machine off anytime you try to forcibly open the case without somebody sending a code to it to say, hey, I'm doing maintenance on it right now. So we've got physical protections built into that. If the data set was really important, we can encrypt that and internally install a USB key. And so then you would lock the case up, and that would be hidden there as well. But if you wanted a distributed model, for example, like the Golan model also, you break up the distributed set with its own encryption key, and no one node has the entire data set at one point in time. So those are kind of the three ways that we handle it from an AI processing perspective. Yeah.
Great. Sounds like you've really thought through a lot of the design questions.
Yeah, so I mean, we're still always making improvements, and we get a lot of feedback, and then there's a lot of technical stuff also as well. But a little bit at a time, we try to build that up.
Yeah, you mentioned that there's a lot of opportunity for placement, especially in the U.S. How many of these devices do you have placed, or how many are you looking to place? You have the Generation 1 still that you're putting out?
Yeah, so right now, the Generation 1, there were about half of them that were sent to a test site in Miami for another potential investor that was going to look at them. And then some of them are in our assembly up in upstate New York, and then some are in New York right now. And our goal is to distribute those, a few of them to India, Turkey, and into Peru, is what I mentioned earlier. But our main problem isn't getting people who are interested in hosting the device, or even talking, for example, to libraries or schools. There's a lot of interest there. Our main problem is capacity and production, and just getting capital to increase the scale of the assembly, increase the supply chain priming, and to have local assembly facilities in the other pilot countries as well. That's really the issue is right now.
Yeah, I see you've got definitely some big goals to get the units out here.
Yeah.
And so what are I'm not sure if you want me to show those other slides about the fundraise, but do you want to talk a little bit about what your fundraising goals are right now?
Oh, sure. Yeah. In this, we're calling it a seed round because everything that we've done so far is bootstrapped or bank finance. So we're looking to put together a $5 million seed round, and that's through private equity selling, so through share selling.
Okay. Excellent.
We can also do it through private token sales as well. So we're talking to a group of people on the token side. We're talking to a group of people on the equity side. Me being from New York and being more familiar with how things work on the private equity side, that's the side I'm pushing. But yeah, I've got other colleagues that are trying to push the token side as well. So however we can do that, that's our goal to raise that round.
Yeah. How do you see the token side fitting into that this equation?
Yeah, so the token part's got two pieces. So there's a part that's it's like a stable coin basically, and that's used. That's an ERC-223 compliant token that's used for inventory and revenue tracking. And so this allows us to basically know where all our devices are, where the parts are, and it also allows us to run our own private blockchain, so-called eating your own dog food, right? You're basically using your own tech to show that you can control this inventory very well. You can figure out what revenue it generated very well, and so forth. And then there's another part where we had it associated to what we call a dividend coin, where it's weighted out against 50% of the revenue that we generate also. And if you look at our revenue models, we've taken that into account as well. We're looking at, for the crowd sale, maybe to change that to be an incentive-based token, so that people would get rewarded by tokens, and in addition to having their electric paid and so forth. But we haven't finalized that model yet. So right now, if you hold a ServerCube coin, it's going to attach to a weighted share of 15% of gross revenue, basically. That's how it will work.
Oh, okay. And is that paid out in the stable coin? Is that?
We're thinking of doing it either that way or doing it in just straight up fiat payments. And then the reason for not knowing is really has to do with tax laws and securities laws in these various places. And in countries like India and Turkey, there's no problem to pay out in fiat, whereas there's questions about whether they want to have the use of something that's considered a crypto on an ongoing basis. Whereas in the US, I think there's more flexibility at this point in time.
Fair enough. Fair enough. So excellent. So now the bigger picture of this, you get the second round going. We get these ServerCubes second generation going out there. We're going to be able to go to our neighborhood libraries and sort of get people, get these institutions connected and receiving some services.
Yeah, they would receive either if they wanted the electric payment or things of that nature, or an additional Wi-Fi spot. They would generate a revenue by running the device. That's the idea, correct?
Excellent, excellent. So yeah, well, I think we've pretty much covered everything that I recall being super exciting about ServerCube. I think that Stephen, are you going to be receiving, or we're figuring out timing to get the ServerCube up to Stephen's office at Transcend Engineering?
Right.
Yeah, we just need to rendezvous.
Awesome.
For that.
Awesome. All right, great. Well, thank you guys both for joining me. Hang on to the line. I'm going to disconnect from the live feed. Thank you to everybody who has joined us today. Let me turn off the screen share. Yeah,
thank you so much for having me. So we appreciate it. Thank you.
Yeah, thank you. Thanks for the work you're doing, and thanks for joining us, Stephen. You guys have a great day.